to everyone? Like, can somebody unmute and
Yes, sir. You're audible.
Yes, sir.
Yes, sir.
so yeah. So haven't like everybody has seen the lectures, or have you
Yes,
went
sir.
through the lectures?
Not completely, sir.
Okay. So, but it's been, I guess, so long, right? Okay, you all were waiting for the result, I guess, huh? So how was the result for the quiz first?
Really bad.
It's bad, huh? Okay.
The results are out of how much marks?
Like it's respect, like if you are getting out of 50, then we'll multiply by 20, like 2. And if
So,
that is okay,
so if the scores are out of 100 or it's out of 50?
it doesn't matter, no? If you are getting like 20 out of 30, like 50 or 40 out of 100, both are same, right? If we are calculating on the basis of 50 marks, and in if
Right.
we have to normalize that, so we'll
So in the
Understand.
dashboard, actually, like, only the marks, or it is marks or percentage, what it is not mentioned. So for us who has got less than 50, it is like we are not able to,
I guess it's marks
understand.
out of 100 then. If you are like, many
Uh,
of you would have got like 70 also, right? Then I guess that's the percentage, I guess, out
Yes,
of
sir.
100.
Yes, sir. Percentage, sir.
Yeah. So does that help, like that wording part help you? Like many of you would have got some like more marks because of those things, whatever we have implemented, right? For the step, like for the steps questions, like if the question is of 2 marks, we were giving half marks, like 1 marks for if you have written the correct options or the steps. And if that question is of 4 marks, we were giving 2 marks out of that. So I it was good for you, right? I guess five or 6 questions were there, right? So what was the issue? Like I can see the result, like only 50% of you have like crossed the passing marks, 50 or 51%. So what was the issue related? Like some of you told the paper was lengthy, right?
yes, sir.
Yeah, in 1 hour it was not doable.
Okay. But the thing is, most of the questions were already discussed somewhere, like graded or assigned, or in the live session, somewhere it was discussed, right? Most of them were like, you don't have to derive anything in the exam. Most of them you can use directly the sum or other part which have been discussed in the lecture and all, right? So it was not that difficult, yeah, but some that extra question would have taken some time, like 5 to 7 minutes for that 5 question. So that may would have impacted. But yeah, we are working on the feedback, like whatever we have got for the quiz one. So we'll try to minimize the number of questions this time. So last time it was around 18 questions, right? So we'll try to reduce that number of questions. And also this time the syllabus would be from 5 to 8. In that 1 week is not like a refresher week. So you don't have much of the concepts. So you can perform well in this exam, right?
Sir, 5 to 8 or 1 to 8?
Sorry, 1 to 8, but most of the like questions would be from 5 to 8. A very less number of questions will be from 1 to 4, like 1 or 2 sort of question. Those, and if you are asking from 5 to 8 also, so some of the concept would have been used. Okay, not totally, that won't be from totally from 1 to 4th week, right? So most of the question will be like, you can expect most of the question from 5 to 8 week. Only a little bit, like a very less chunk of questions from 1 to 4, like maybe 10% or 20%. That's it. So at least you are having 80% of question will be from 5 to 8th week, right? So in that 6th week is not like it's a refresher week. So you'll be having 5th, 7th, and 8th. And 7th is pretty simple. You don't have to go deep in all the concept, whatever the professor like Andrew sir has proved. You just go through the, like, if you'll go through the result also, that will help you in learning the aspect also and in the exam also. So, but yeah, so most of there are so many results I can see in the weeks happen that it should be there in your mind. And if you'll try to solve any of the questions, most of the question will be whatever has been derived in the class. Okay, so I don't think so there will be any problem in 7th week. 5th week is also not that like broad, like yeah, 1st to 4th there was a bit jump from stats 1 to 2, so it was a bit difficult for you to grasp. But I guess 5th to 8th is not that difficult. You can perform pretty well. Like 5th week also I can see is I've not seen the content mostly, but 7th week I've seen it's not much is there in 7th week. And 8th week is also mostly the estimation part. So that is also not that difficult. So you can perform pretty well in this quiz too, I guess. So yeah.
But sir, in the 7th week, we are jumping towards the statistics part, and the sudden upliftment has gone into the course. So understanding the concepts became quite difficult for us because it is going towards the statistics part more. So the concepts like MGF, all these terms are new and are difficult to understand, and also the implementation towards the activity question which we are doing. It's like, okay, it's fine, it's not that much tough, but we can't say that we have a clear idea of what is that. Actually, we can say that we have slight idea, like this is this thing, this is this thing, but we can't say it confidently that yeah, I know this MGF part very well. So
Okay.
this is what happening with me. And I think
Yeah.
this part, because we are jumping towards the statistic things, now things are becoming more complex and difficult because we are applying the concepts. Yeah.
Yeah, correct. So what you
Sir,
can do? Yeah.
Sir,
So
do we have any extra books for those approximation using CLT theorem like that?
Books you are asking?
Yes, sir. Problems for related to CLT approximating normal
Okay.
distribution.
That I guess it has been shared. I guess you can check it on the portal. Otherwise, I can share on the discourse. Like I'll check whether I'm having, because I'm having 5-6 books. I'll check where it has like CLT and all is there. I can share it, but I guess it has been shared already on the portal. But I can remember like 5-6 book has been shared.
In total, only 2 books has been shared, out of which book will have this contents.
Okay, then I'll try to find if I'm having any book and share on the discourse, like on the I'll tell the team member to share. I'm having some books, I guess, but I'll try to share that. Okay, by today evening. And if I won't be having, I'll search for some books if that is available somewhere on the Google, or I can arrange. Then I can say. But I guess if you're trying to solve most of the questions of the as activity, that will cover all the concept. Like most of the what is the final result? Whatever you have to like grasp the thing. Like you don't have to go to the proof and all. That is not required, and nobody is asking also. But if you are going to the proof, that is fine. Okay, but you should be able to remember many of the concept. Like if I'm having normal distribution, I'm doing n times that normal, so the final result will also be normal. So those type of things should be there in your mind. You don't have to go through the like why I'm writing this NGF in like this form. This type of questions, okay, this can arise because we are like reading for the first time. But the final whatever the final result has came, that is very important. Like many of the, and the thing is ki very many of the things like, and somebody was asking about the distribution. So the distribution also in the formula you'll be getting some distribution, like if you are not able to remember like gamma, what is that alpha beta, so you don't have to think what is that alpha and beta in this aspect. Like you can remember also, and mostly you'll be giving the formulas also regarding the gamma, beta and all. I guess in the formula it was available, right? The formula sheet, it was already available. So you should be able to know okay, how can I relate, or how can I tell whether it's a beta or gamma sort of things, okay, or normal distribution, or it's exponential sort of things, like by graph and all. Otherwise, you can just remember, okay, this density function is in the form of like x and 1 minus x to the power something like alpha beta, and then this will come in beta when the x values is like very less from 0 to 1, because we are taking x and 1 minus x. So whenever in the graph the values of the x is from like in the form of decimal, so you can directly tell it's a beta. Those type of things you can remember, or you can say you can grasp it in your mind. Okay, if you are having problem in differentiating between gamma and beta, so this is the one important thing that you can observe from the graphs. So this type of things you can relate, or you can keep in your mind. I'll tell. So you don't have to remember everything out of that. Why I'm dividing it root n, why I'm dividing it n, and all those sort of things. So those are like has been done like many of the excuse me, sorry. So those had been done in hit and trial methods, and then after doing so many experiments, these are the what you can say the chunk part that is very much important, and that has been done nowadays. Okay, so those sort of like important example or the final results should be having in your mind. I'll tell. Yeah, like there were having, I guess, 8 to 9 lectures in the 7th week, and the first second, I guess, was pretty simple. The sir has just told you about the, I guess, the data set and all. Okay, so which sort of data set, like he has discussed some of the data set, I guess. And then from second of the lectures, he has just discussed if you are having some this sort of very distribution, but you don't have, you just have the sample thing out of that distribution, because the distribution can be a very large number. So you mostly, whenever you'll work on the data set, you'll be having a sample data only. So how you can go to the like how you can tell about the distribution without knowing the distribution only from the samples mean and all. So those sort of things are there in second or third like lectures, and then you'll go through the you'll be calculating a probability such that probability, you'll be calculating probability sort of things with the help of Chebyshev, and then that exponential thing, that MGF and all will come. Right, and then you'll be going through the sum of the distribution. In between, you should be able to write the MGF of anything. Like if you have been given, like you were able to write the expectation, like in the earlier or in the stats one, you read about the expectation, how you can write the expectation, how you can calculate the expectation. In a similar way, you should be able to write the MGF, and with the help of MGF, you can calculate many other things. Like if somebody has given you to calculate the random distribution or the final range for x square or x cube, or you can if somebody has given you the distribution and that distribution has been repeated 5 times, so after that 5 times, what will be the range for those things and all. So those sort of things can be done very easily with the help of MGF, and then in the end you'll be going through some of the distribution. So those distribution, and there are some final results also, like if I'm having gamma, so for those gamma, like if that alpha beta is there, so the mean will be alpha upon beta. So those things you can, I guess, if you'll go through 2-3 times, you'll be able to like you won't forget. Okay, so what I can do, I'll just okay, I'll share the books and all. So I'll just write some of the important, what you can say, important result in the 5 minutes, so that. But you already would have made the notes, or should I write the important things from all the?
Sir,
Like,
please write important things from all the lectures.
okay, so I'll write only in the 1 or 2 pages, and that will help you to, I guess, solve the most of the questions. But the thing is, solving the question, clearing all the concepts, bit difficult, different things. Okay, so you can solve the question whatever I'll write on the page. Okay, but to clarify your doubts, you have to go at least once or twice through the like 2 videos. I guess the starting videos are pretty simple. If you go through the videos with like increased speed also, you'll be able to grasp like first, second, third video, fourth video also. But 5 and 6th video, you should watch it twice, right? And then 7th and 8th is just you have to remember the final result. Okay, so 7th, 5th, and 6th you should watch twice or thrice if somebody has not seen. If somebody has seen and is not able to grasp, so what you can do, you can watch that video twice. Okay, 5th and 6th, that's it. Like that is of 40 or 40 minutes. So that will take 80 minutes. And if you are watching it twice, that will take 160 minutes, so 3 hours. You have to invest. Other than that, 7th and 8th, you can just go through that. You have just have to remember the final. Even from the week, like 5th and 6th lecture also, you just have to know regarding the final result. But if you watch, you'll be having a bit clear clarity. Many of the things sir has also not proven, but that is not required at all. Even he has proved so many things, but that is also not required. Okay, you just have to go through the final result. Okay. So I'll write some of the important, like what you can say, result out of all, like from first, even from first to eighth, what are the lectures. I'll not write the sample mean and sample variance and all, because those things are pretty simple. I don't think so you'll be having any problem in that. So, and then we'll go through the question, each and every question, because many of you have not solved that, I guess, the activity and the practice. So I'll try to solve this into our, okay.
In one of the previous sessions, Nikita ma'am has informed us about the website for books. I would like to share it some of the people who are keen to know for the website. So
Yeah.
the name of the website is LibGen, LIBGEN, where we can find the books regarding these statistics.
Okay. So yeah, so this link has been shared. Somebody has shared this already. So whoever wants to go through or want to practice more books, you can just watch this, what you can say, website, and then let us know whether you're able to find it or not.
So one clarification. So in some of the cases, we are finding CDF of Z, FZ. So sir, if always the FZ value would be given to us, or if it is not given, then how we should calculate it?
No, you can't calculate. That value would be given, or you'll be given some Z, like one seat is there for Z seat. Those values generally, like those seat will be given whenever you'll do the hypothesis testing and all. So those Z value will be given. Okay, so don't worry about that. You don't have to calculate Z value. Okay.
Okay.
I had a doubt regarding extra activity for week 6.
Okay.
Okay, actually, how to approach it? I mean, should we take our own set, or should we? There is some example data set also given, so it should be those should be taken up. That is one question I had. Second, suppose I had taken some data set, and ideally when I do a histogram, it should show me what kind of curve it is.
Yeah.
But I have, when I took that and when I do the histogram, I mean, it is not close to anything. So that also, because so what I feel is, if we can have some like data which we can take, and then we can, if you can just show us like, okay, this is how the distribution is now, see, this is how it's basically applying it, that would also really help.
Okay. But the one thing is, I don't know the question. What was the question? I have not seen the extra activity thing. But can you explain me once? I'll try to, maybe whatever I'll get, I'll try to explain you. What is the like proper, you have, okay,
one
from
question,
the data?
One
Okay.
question was on, like, you could take a weight of the birth child weight and then see that it's a normal distribution.
Yeah, it will be a normal for sure.
Yeah, so but when I put the value,
Okay.
suppose I get download.
So what was the
value.
bean you have taken, like bean value?
So it will be based on what the data is, right?
Okay, okay, but you can like take it like 5 kg as the bean or 10 kg, and then try to see that whether which of, like changing the bean value, whether you are getting a better normal distribution or not. That also you can try once.
So should I not should I not do based on the sample mean? I mean, whatever sample I'm taking, and based on that, the mean which I get.
Okay, so
so that is a problem. I think if in any one of the session, if not in this also, if any other session, if we can get,
what is the like final date for that submission?
It is
16.
Oh. Okay, so, yeah. So tomorrow Mayur will take the session. He's like in charge for that. So you can ask tomorrow. So I'll tell him to wait for like after the session he can wait for some time and he can explain. Okay, will that be
Oh.
fine?
Yeah, that should be fine. So basically, what at least I am, or maybe everybody is feeling difficult is that. So once we have the actual data set, how do I approach it to whatever we have learned?
So in the what they have asked to show ki whether it's a normal distribution or not. That's it, or they have asked
Yeah.
other.
Yeah, so
Okay.
basically we need to prove that we need to calculate first and also see that
Okay, so
our
you have
calculation.
you have to get the data also, right?
Yes, yes. So
Data
based
to-
on a calculation, it should fall into that category. So, but when I actually look at any sample, somehow I don't know if I am doing something wrong. It is not falling in any of those.
Okay, so
I'm
can
also facing the same problem in this kind of questions. We have to collect the data. I was collecting data and I was calculating the mean and standard deviation from Google Sheet only. And when I'm making the graph, the scatter plot or any other graph, I can't see any kind of distribution in that. It was just like exponentially increasing or something like that. I'm not
Yeah,
finding it a normal distribution or a Poisson distribution and anything like that.
So
And we
what you are
have to
doing, you are just
calculate it.
sigma. You are calculating for all those data, and then you are calculating sample mean. Mean values, and then you are putting
Yes,
in the
sir.
normal.
And sir, there was sir one thing we can use norm dist. Norm dist we have to in Google Sheet, and
Okay.
we have to put the mean, standard deviation, and then the columns we have to select, which will find the I think it would find 0 point some probability in
Density.
distribution, and then we have to plot these curves. Yeah, density, and then we have to plot the curve using this. Suppose I have taken marks of the students of some class,
Okay.
and then we have calculated using this norm dist the density, and then I was making the graph, and the graph was not being like this is normal or what, this is bell shaped. It was something different, and we can't get any information regarding this, any information about the distribution, how it follows.
Okay. So, but maybe you are doing something wrong, because see, these are all examples. You can get it like normal distribution pretty simple. Like it's a simple, like if you are getting any data like weight or marks and all, it should be normal distribution mostly. It should be a normal distribution. It can be a like right or left skewed, that is fine, but it must be a normal distribution.
Sir, can you tell me how to collect this data?
Collect the
From
data.
where? Yeah.
You can collect the data from Kaggle. Is a like having a lot of data sets available.
So which Kaggle?
Yeah, Kaggle is a website from where you can get the data set.
So can you tell me the spelling?
KAZZLE.
Okay, okay.
That is the one. Okay, and you can get the data from like GitHub and all. It also provides, like many of the person generally worked on those data. So those data set you can like CSV file you can take out. And then
So I think there was also one mistake from my side, because I was taking a random data which comes to my mind. Suppose I have taken the random name. Suppose I'm taking Nitin, and he has scored 68 marks, and I was just putting random names and random values. That may
okay.
also be
So
one reason.
even you are taking some random values also. Okay, but yeah, so random values if you are taking, but you have to spread those values. Like, see, now how I am telling that must be a normal distribution, because if you are taking in your class also, in any of the classes, you can see very less number of people generally score very less mark, and very less, like out of 100, like 10 people will score less than 40 and 10 people will score more than 90, right?
Yes, sir.
And most of the people will score the marks that is around the mean value, right? Like out of 100, most of the people will score around 60, 70.
Yes.
So that is why we can say directly it's a normal distribution. But if you have taken the data randomly, you would have taken all those data between some sort of values like 450 and 470, most of the data set out of, if you are considering out of 500, but you have to consider those marks also, like 200, 300, like where maybe like 10 to 15% students who are not that good in like in studying, and there are some 10-15% who are brilliant, but most of the people generally lie in the average and above average people, right? So that's why we generally directly we can say, if you are having some sort of, like in the weight also, many of the people will be having a very less chunk of people will be having the weight more than 90 and 100, right? And very less number of people should be having weight less than 40 and 30, sort of thing. But most of the people will be having the weight between 60 to 80, right? 60 or 50 to 80, some sort of things. That's why it's a it can not perfectly normal distribution, but like resembles the normal distribution plot, right? So one thing, if we are having data and you have to directly see it's a normal distribution or not, you can directly like plot the histogram with some bean, and then you'll get okay, this is a normal distribution. But it's a one way. I don't know which way have been asked to like can be done in that whatever has been asked in the extra activity. But this is the one way. That is how you can.
So in activity, it was asked like we have to perform the calculation regarding the probabilities from the data, and then we have to construct or plot the graph or histograms.
Okay, so those I guess in the Google using that Google form, like Google, what you can say, Google Excel, right?
Yes, sir. Yes, sir. I have done in Excel.
Okay, so in Excel also, okay, there are some functions that I don't know because I generally work on the Python. So I'm in the Python also there. So in the Python, so if you are having some CSV file, you can just use one like normal sort of like one library, or you can say one thing is there that you can use directly, and you can see whether it's normal or not. But in Excel, I don't know. But in Excel, you can do this thing for sure. You can just take some bean and then plot the histogram, and then see it will come for sure in the normal distribution. Can be some left or right is good a little bit, but most of I guess it's a normal distribution one. That is one way. Other than that, he can like Mayur can tell you in the tomorrow session how like he is expecting you all to do that. But if somebody has done that, he can tell. Many of the person has given the data set, like the search. Yeah, that government data set also you can get from data.government.in and many other data set. Yeah.
So do you think that my random values, the data which I'm taking is very random, and I was just putting the things which comes to my mind, putting the marks. It may not vary accordingly to form the normal distribution. So if I'll take a particular data, good data, which you are telling I should go through this website Kaggle, then it might not create that problem to me.
Yeah, it should not create the problem, but yeah, it will not create for sure the problem. But the thing is the procedure should be correct. That is what I'm telling. If you have taken, sir, the problem with random data is only one person, like only you have given the random data. Okay, if you ask 100 people, then those even the random data, whatever is like, if you are asking only, we are having 77 people. If you ask the 77 people to just give me your favorite number, okay, even those data will come resembles a normal distribution, can resembles a normal distribution. Okay, but if you only one person is giving the number like 10 times, so maybe he can give the number in some particular limit, right? So that will not resemble a proper distribution. Okay.
Yes, sir.
Yeah. So if somebody has done that, he can tell. Otherwise, we'll move.
So suppose if we are taking a share price movement of a company, good company.
Like share market, share price.
Yeah. So
okay,
you won't get that type of distribution.
No, you won't get.
You won't get a distribution like that.
So no, then you won't get the normal distribution.
Because you won't get a normal distribution that one. No?
Yeah, because the thing is, share market price generally remain constant, right? If you're having data for 1 year for like Apple, the data when some sort of things will happen, like if some very popular CEO has told something about the Apple, then only the price can go down or can go high.
If you really take it for a period of 3 or 5 years of specific share,
then also it will not.
TCS or Infosys, okay? There might be noises in between, but overall trend will be increasing. So
yeah,
can you establish any distribution pattern here, or exponential, or
no, it's not. It will not. It will increase a bit. Like if you are taking for the 10 years, it will increase for sure the rate and all, but it can't resemble any.
No, let's take for example the price of a gold, bullions, or oil, or anything. So these are all.
This data set I
moves everywhere. It moves everywhere. I don't think we can fix any pattern on that one.
Yeah, it's not a pattern of normal, that is for Pakka,
So
but
if
it can
you-
resemble some other data like distribution, but because it's mostly it will increase only, right? With the help of inflation and all, the rate will increase a bit, but not much also. But there will be some sort of noise in between, like the pandemic happened, then the price of the stock.
Exactly, yeah. So that is the time. Then how do we really establish any distribution pattern or equation or anything on that?
For the share market and the prices and all, the distribution that
Even anything, forget about share market, any commodities, even if it is a whole
any commodities
consumer
rate
price
will be-
inflation or anything, consumer price index or anything, if you take it, they don't have a fixed pattern. It's almost everywhere, moving everywhere.
but see, in the ML thing, generally, like how generally predict the rate of any commodity. We use some sort of algorithm, like simple algorithm, where we try to get the correlation between, like, if I'm having X, like today's is 14th of Feb, and yesterday was 13th of Feb. So what we generally do is we generally try to get some sort of correlation. Like there are some algorithm like what is that? I am forget KS test and some sort of testing are there. Hypothesis testing. Yeah, I'll read in that hypothesis testing. With that help of those things, I don't know whether we can predict the distribution, but we can do some sort of things with those distribution also. We can't predict because all the data set can't resemble some sort of data like distribution, because we are having only 10 or 15 or 100 data distribution, but the number of data sets can be infinite, right? So so we can work on those data sets. Generally, we can work on those data sets to predict the price of the commodity with the help of some auto correlation function and all that you'll read in maybe next and all. But yeah, we can work on that. But I don't know how we can predict whether which distribution generally it says. We can convert that into normal distribution with the help of some power log and all, but we can't directly tell which distribution is this. Okay. Yeah.
So what is the best ideal data set for our exercises, like marks or weights?
Yeah, marks is best, or weight, height, any this sort of things are like mostly resembles normal distribution.
Excuse me, sir.
Yeah.
So I went for like the number of daily COVID cases for the last 2 years.
That will resembles normal. That so you can see, you can check any of the websites like Worldo.
Yeah.
You can check it's a normal distribution, right?
Yeah, I got a normal distribution for that. But like, should the source be? I took it from a website which is actually like a website which kept track of these things. Like, should it be from an official government website, or like, is there any requirement like that?
I have not read the question, but I don't think so. There will be like this sort of things will be like constant. This constant would be there. You have to get the data set from the government side. You can check you can take any data.
Okay. Yeah, I just wanted to confirm.
Yeah.
Vishal, sorry, I just joined. I am not very sure how you are taking the session forward. I have just joined. How you are taking the session forward? I mean, is there something planned that you have to do, or can we ask questions?
So is the session for week 7 or like?
Yeah, it's week 7. So in the starting, only less people are there, like 15 to 20. So I've asked them whether you have seen the lectures and all. But so I thought of discussing some of the important concepts, and we'll discuss all the questions, because I guess many of the people were saying they have not seen the lectures. But now we are having like 90 people. So you can say what's like, have you went through the lectures and all of
So
7?
I have some doubt in the lecture itself.
Yes, sir.
Can I ask that? 7.6.
Okay.
And the timestamp is
So also the
35.01.
Okay, so yeah, I'll discuss the activity.
So in activity 7.6 also I have some questions regarding that.
Okay, I'll discuss that. First, I'll go to the lectures. Where is that lecture? 7.6, what's the timestamp?
35.01.
35.01. What is that?
Sir, you're not sharing your screen.
Okay, sorry. So what's the doubt in this?
So the observations that are written over there at 35.01, if you can just explain that a little more. I mean, what has come out from that observation, how we have reached the
So
text
how?
from the
Okay, so
lecture
this
is not
one,
sufficient enough.
you're asking.
Yes, the observations. No, the observations. So contrast with weak law of large numbers. I mean,
Okay, so weak law of large number, generally, you know how, like with the Chebyshev we were getting, right?
yes, right.
Yeah.
So I
So
mean, I was not able to understand the link and what is the relevant information that we should carry forward from this observations is basically what I want to understand a little more. So the professor quickly went through this particular thing, like IID tends to be normal and 1 upon n, but what is the relevant information that we should grasp in respect to this observation is what I'm trying to understand.
one important thing, you already know that the MGF of normal distribution is this one. If we are like, if we have any sort of distribution and if we are doing it like for n number of times, right? One to is this one, right? But you're asking about the observation. Constant with the week, okay, that x bar is upon. So when we were dividing one, first of all, in the week w, like whenever we were using the Chebyshev, what was happening? We were getting the things in the form of 1 upon n, right? So the probability that is the part of 7.4, you can say 7.4 or 7.3 in the starting videos, when we were able to calculate the probability, okay, for like, and we were trying to get the boundation. So what we were getting, the boundation, the probability that we were calculated and we have compared with the exact value.
Vishal, can you take an example? So for example, if we are given, there are many questions also in the tutorial and everything. So if we have been given a distribution, right? With this central limit theorem, what are we exactly trying to approximate? There is something called as E lambda square sigma square upon 2. That is the theorem. But what exactly are we trying to achieve with this central limit theorem? When we have been given an exponential distribution or when a normal distribution is there and we do certain changes, right? I mean, we modify, right? And then we come to something Z.
Yeah, in the form of this, like if you are
Yes,
having,
exactly. So with this particular theorem, what are we exactly trying to achieve when we have been given some normal distribution or exponential distribution through
so
some example?
if I'm having y sort of some random distribution, okay, right? If I'm having some y in the form of x1, x2, and x, these all things, I guess you're asking about the proof and all. The proof and all is not important,
Not
but
the
the thing,
proof. I'm not talking about the proof. I mean, proof is fine, but something from the visual graph, if you can tell, again, taking an example, this is a distribution that comes, and then with this particular distribution from the graph, we are trying to derive this. I did not find anything of this particular sort in the lecture, and it is quite difficult to interpret what is happening.
so this
These
one, I
steps and
guess,
everything is fine.
yeah. So this has been discussed, I guess, in the lecture also. How that is converging to a normal distribution. On why we are doing this, because if I'm getting some sort of normal distribution in the form of 0 and 1, we can, like, we'll be able to, like, what you can say, you can that we will be able to say, like, with the help, if I'm having some sample mean, so now we'll be having more confident, because this got converges to a normal distribution, not same like exactly, but it got converges to a normal distribution with 0 and 1, like mean 0 and 1 variance. So now we'll be able to tell the probability aspect of those distribution, right? I'm having, like, for example, x1, x2, x is some sort of IID, and then if I'm for y, if I have to tell anything, so with the help of this theorem, we'll be able to, if I'm doing this sort of things, y minus nu, like y minus x, like sample mean upon root n times of sigma. So now this distribution will be in the form of normal distribution with 0 and 1. So now we'll be easily can say regarding the probability, not the exactly, but more or less similar sort of probability we can say, right? Like in the example, one example was there, I guess I forgetting what was that. This data set was there in the starting, IPL or what?
Iris dataset.
The Iris dataset, yeah, it's there, but that how will you use that? But with the example, the question you can maybe with the activity question you can relate, like not with the activity question. Yeah, there are some questions that you can't solve without using this aspect, right? That is not, I'm telling just to solve the examples and all. That in the normal life also you'll be getting some sort of distribution that you won't be able to, you won't be able to like deal with. So if you are able
So,
to,
no, Vishal, my question is, for example, in tutorials, there are many questions that please approximate using CLT. We approximated using CLT, but what is the interpretation of that particular answer, or what is it that the question is trying to ask after we have used the CLT theorem to approximate, is what I'm trying to understand. So this is fine. The bit of explanation that you have given, that we can use the probability features of normal after we have approximated, makes sense.
yeah. Z equals to minus 14.6.
So if you can take a tutorial question and then relate with the observations that were written, it will make a lot of things clear, at least for me.
Okay.
With the lecture and the tutorial questions, I mean, we read the lecture, and then when I have moved on to tutorial question, that link is not coming in terms of what to use, which formula to use, how those particular steps can be formed in terms of the tutorial question. At least I'm not able to come to that particular stage. Hence, trying to understand what exactly is being said in respect to CLT so that we can relate with the tutorial questions also then.
In the first tutorial, there is nothing related to that, right? First is pretty, all the
Yeah,
questions are
not
like,
the first. It is the second tutorial where CLT is usually the questions are on CLT.
yeah, if somebody was asking regarding the Z value, so he has written correctly. So which questions should I explain? Like from, okay.
Any that you think appropriate in respect to the question. So for example, if we take this question now, CLT, using the CLT theorem, something has come, right?
Yeah.
But what does it mean then?
See,
it is larger. Can you just scroll down a little?
Yeah, this one, right?
Just scroll down a little. Yeah, so with this fz, we have got something as probability 1 minus fz, and n equals to 10, delta is equal to 1. So what exactly is this interpretation, and how can we really use it to understand what has been calculated?
Okay, this FZ, so I guess you have read, but I don't know what should I explain to you. What I can explain is the questions and the solution, but see, CLT generally, okay, that you already know, but I don't know what. Can you repeat that?
Okay.
Yeah.
Maybe what we can attempt in this case is that what kind of problem statement takes help of CLT, and if CLT as a concept is not there, what is the problem will happen? Maybe that route we can take. Under what? So if you can just help us on that one, because this is a problem to me also. I also went through the lectures. CLT as a concept while I'm trying to understand central limit theorem, and the concept wide, if I understand, it means if the samples are drawn from a population for which the population distribution I am not clear about.
Yeah, population distribution is not given, just a sample you are taking out from some distribution.
And if I do multiple samples, similar samples, if I take it, as the number of such sampling increases, then the sample mean itself will behave like a normal distribution.
The sample mean will divide. Yeah, correct.
So that's the overall concept of central limit theorem. That's CLT. But now, finally, how does that help to get, what do I get through CLT? If you can just help understand that thing. So for example, this theorem doesn't exist, then what kind of problems I will not be able to do? And through CLT, what is that I am able to do? Maybe that one?
1 second, I'll just come in one
as
minute.
A concept of, so the motivation behind CLT, why is it important?
1 second, I'll just come. Somebody had to do it. 1 second.
Sure.
Yeah. So you were asking about the CLT. Already you all know, okay, that if we are taking out the mean, so it will come in the form of normal distribution, right?
Yeah. So let's just go through one. Let's take it this way. One problem statement on how have we come to the solution of it. Maybe step by step, if we go through, maybe in this process, we would also be able to articulate in a manner which is suitable for you to explain it to us. One specific question and end-to-end solution there to why steps are being taken.
See, this is the yeah, if this is a question, if I'm having some sort of distribution, right? This distribution, if I'm having, and this distribution I'm repeating for the n times, right? Okay.
Yeah.
So if I'm repeating this for n times, so one thing from the CLT, one thing we can take out this, if I can get it in the form of this, so this will be in the form of normal distribution.
When you just say that you're repeating for n times,
yeah,
can you just scroll up?
Yeah.
So over here we have x as -3, -2, 0, 1, 4. So when you are saying, when you repeat it for n times, you mean to say -3, -2, 0, 1, 4, and then further values, right? That is what you mean to say, or you mean to say this 5 set repeated many times?
See, like x1 resembles this one function, this one set of, you can say, probabilities values. And this is been repeated n times. Like I'm tossing the coin for one time, and the tossing the coin will be having 0 and 1, right? With the probability half. So similarly, this random variable will be having 5 outcomes with some probability. This has been repeated n times, because for this we don't know anything, right? So this has been repeated n times. Okay. And for the summation of that, the summation for that, I have been asked regarding the summation for the probability of some delta n. So one thing we know from the final result, if I can see y is not directly, can not be directly in the form of normal, But if I somehow get the help of some CLT theorem that has been done, some hit and trial method, like dividing with root n and all, and the end we have got the normal distribution with 0 n. But one thing we have to do, we have to get in the form of this, then only we can say this is in the form of normal distribution, right? Like any experiment can come in the form of normal distribution, but we have to do some sort of things with the y, like y minus mu n upon that, what was that, root n into sigma. And that will come in the form of normal distribution that you have to do with the head and trial method. Okay, one thing should be there in your mind, if I'm doing some sort of experiment, like n number of times, okay, so we will, with the help of CLT theorem, that CLT theorem, we'll be having some sort of things in the form of y that will converge to a normal distribution with 0, 1. And from there, we can easily get the probability or whatever has been asked. Because if I'm having normal distribution, we are having the distribution, because here we don't know regarding the, we generally don't know about the distribution. We have only, like, we don't know about the distribution. So in the end, if I'm having some sort of like distribution 0 and 1, so from 0, 1, from that normal distribution, we'll be able to calculate everything, like whatever has been asked. Like that's not the exact one, but approximately that will be similar to that normal distribution, right?
Yes, right.
So that is what has been generally, that is why we generally use the CLT theorem, like in most of the, if I don't know regarding the exact distribution earlier, if we are having the sample values and all. So with the help of this, we can get some sort of values out of that. Maybe that is a bit confusing, but what I'll suggest you to watch the lectures again, and then you can message or text me. That is what I can suggest you, like everyone. Because 5th and 6th lectures is a bit like because you are moving directly to the, now you are moving, you are using all those concepts, whatever you have read till now, and now you are using those intuition and those concepts now in the statistics. So a bit jump from there.
We have skipped, at least I personally have skipped lecture 5 because in one of the classes it was said that 5 may be skipped. So
no, what
that
I
doesn't
say
impact
is you should not skip the 5th one, but see,
because
there are
one
8
of the
lectures,
theorem,
right?
Yeah.
So I guess one is regarding the data. Second, it's simple that you can watch with the increased speed. Okay, that you should not skip, but you can watch it with double speed or 1.5x speed. That is regarding the sample mean and variance mostly. And again, the third and fourth, third is again some sort of like data thing and all. From fourth also you can watch with 1.5x speed, but 5th and 6th you should watch total. That is around 80 minutes. And you can watch it double also, twice, 160 minutes it will take. And 7 and 8, you can not skip, but you should at least go through the PDF, like whatever sir has told. Just remember all the, what you can remember, or the final results should be knowing. It's not because I'm telling you, you'll be able to solve all the questions, because that will help you also in the, when you'll move to like up like other courses and all. Or you can say whenever you'll do some sort of like you'll work on the data set. So the final result, like if you're having some sort of to like, I'll write some of the important, like what you can say, results out of that. Like if you are having some sort of
Sir, I have doubt in activity 7.6. May I ask?
Yeah.
In activity 7.6, question number 2.
Seven 7.67.
So also one thing here. So someone in the discourse forum has posted the solution for question number 3. And there it was here, he or she has mentioned that x bar minus mu upon sigma divided by root n less than something. So, in this kind of thing, where we are normalizing the question, we should
This is
x
the
bar
normal.
sigma under root root n. So
So what was
we
the
should take.
use? This is the same thing, right? X bar, or if you are writing in the form of what?
The formula was like y something like, and it was in the denominator part. It was multiplied by root n.
Yeah, but this you can write, right? If you are having same sort of samples, you have been. This is what? This is generally the summation of x.
Yeah, this is x bar by n.
Right, x bar by n. So if you are writing this, and this is for the one, like one, what you can say, because this has been repeated, and this x is same every time here, right? In the question, that's, or you can write it in this way also you can get, but in the end you just have to write that y in the form of x. Like for this question, see what you can do, how you can get from here to here. Sigma is there, right? So if you're writing y here, x upon n minus n x bar.
So y will be x bar n.
Oh yeah, x
Yes,
bar
sir,
n.
x
Sorry.
bar n.
X bar n, right? Minus n sigma. Now you'll get, right?
Yeah, okay, sir.
So n will be common, and then it will get, yeah. So n will be here, and then x bar minus nu upon sigma, and then this will go here. So now you can calculate, right? Now you have.
So now this could be considered as z.
Yeah, now you can consider it, and with the help of that CLT, that yeah, this can be considered as z now, x minus nu upon nu sigma, right?
Yes,
This
sir.
one, and now
So
what you
this
have to
y
calculate?
thing is also the same part. Then also we can say it is z. Y minus n mu. Okay.
Yeah, because we have derived this from the same formula, right?
Okay, sir.
So now what do you have to calculate?
Question
Now
number 2.
you'll be able to solve, right?
Yes, sir. Yes, sir.
Okay.
So question number 2, sir, can you explain that?
Question number 2.
Yes.
This, we were solving this question only, right?
Yes, sir.
Okay, so what is the here, find the probability that the average number of cherries in 64. So we are doing this 64 times. 64 cherry stuffs will be less than 7. So we can approach with the same thing, right?
So I have found here the mu as 7 and sigma square is 5.
So now what you have to calculate, x minus nu upon, what is that? Sigma
upon root n. Yeah.
Should be greater than or less than? Greater than 7.
Yeah, it
Sorry,
should be less than 7.
So less than 7 minus sigma by root n, right?
Yes, sir.
So what is the value of sigma? You have calculated. Nu and sigma you can calculate from the distribution given.
So it will be 0.
Sigma is 0. Sorry.
No, sir, mu
is
7
0.
minus mu would be 0.
Okay. So and the sigma is how much? How much it's given?
Sigma square is 5. Sigma is root 5.
And n is 64. So 8, right?
Yes, sir.
And 7 upon. So this you can write probability of anything in the form of this. And this is the distribution of normal 0, 1. Okay. So what you can write? Root 5 upon 8. So this is simply fz of this one. right?
Sir, can you scroll up? Yeah. So here mu is 7 as we have founded it using the
Mu
expected
is
value.
7 or 0?
So mu is 7. So the 7 minus mu will come out as 0 now.
Oh, okay. Mu is 0. Sorry, mu is 7.
Mu is 7. Yeah.
Then the value directly will be 1/2.
So how fz of 0 is 1/2? Why it is so?
See, because we are having distribution in the form of this, right?
Yeah.
And if this is the mean is 0, so for this area, the value of probability would be 1/2, right? And for this area, it's 1/2.
Okay. When it is symmetric about the mean.
Yeah.
But sir, here mu is 7, now it's not 0. So why we are taking this?
No, I'm taking, I thought mu is 0. So I saw it like this. Otherwise, if mu is 7, then
Yeah.
it's simply this is less than 0. Okay, then this is the fz of 0. So 1/2 should be the answer. What's the answer?
So that's the thing, na sir. I'm asking why fz of 0 is written as 1/2.
Fz, oh, see, fz of 0 is what? Probably fz of 0 is what? Probability of this z should be less than 0.
Yeah.
And probability of z should be less than 0 is what? This area?
Sir, but in this graph, you have taken mu as 0, no?
Yeah, mu I have taken 0. See, what is that normal distribution generally? You're having this plot.
Yes, sir.
Okay, with mu as here, right?
Mm.
Hmm?
Yes,
And
sir.
what is generally right for this fz? Some sort of equation to sigma e to the power minus x square by 2. If we are having 0 and 1 as the, okay.
Standard normal distribution.
Yeah. So if you are not having, you can, if you are not able to visualize, you can just integrate it from -infinity to 0. You'll get 1/2. That is the one way. Or you can say directly from after mean, the value of this will be half, because it's a total like well-shaped, or you can say symmetrical regarding mean, like about mean value. And here mean is 0, right?
So I know that normal distribution is always symmetrical about the mean. So that's not the thing I am worried about. But you have said here that the mean is 0, considered here in this graph as 0. So in our question, the mean is given as 7. So why we are taking it symmetric?
What you are okay, it's 7. I'm writing it mistakenly, but this also will be 1/2. So don't worry, I'm just writing it mu. Now it's fine.
Yeah, okay.
Whatever the value of mu, you don't have to worry about that. Okay, if that has been asked regarding fz of 0, so every time it will be 1/2. Okay.
So also the third question in this.
So the third question is why just sum of random mean is 0 after centralized. Yeah, that is one way to centralize. So whenever you have to calculate the MLF, what was that? MGF, yeah, moment, then you have to centralize it. Okay, and what is the, without CLT you may not be able to require to give, yeah, for different samples what could be the mean. So what was that? Second question, third question.
Yes, sir.
So for the third question, the question is an electrical firm manufactures light bulb that has a length of light that is approximately normal. Okay, so that is normally distributed. So with mean equals to 600 hour and the standard deviation is sigma is 50. So find the probability that the random sample of 25 bulb will have average life less than 615. So here also you can use the same method, right? So what you have to calculate here? You have to calculate what? Probability of what?
Probability of y. Yeah, y is less than 615.
Right. So now using that CLT, you can go till where? So what was the value? Mu is 600, right?
Yes, sir.
Sigma
Standard deviation is 50.
and n is 25.
25, yeah.
This not mean this is expectation, expected life, right? This not okay. And to get normal, what is that? Y minus this is normal. Right, whatever the distribution, we don't care about the starting distribution. It should be normal, right?
Yes, sir.
So now what you can do, in the expected value you already know. So here also you can use that the starting method. You just don't use this, use this one. What was that? N sigma upon root n.
Sigma root n, yeah.
Use this one, you'll get. Okay.
Sir, why this one is preferred, sir? X minus mu.
Which one? This one?
Yes, sir.
So the same, this we were already know, right? Okay, so y is what? Y is simply the x1 plus x2 n times, right? And x we know this is totally identical. And this has been like what we are doing, we are just repeating the same thing. So x1 plus x1 plus x1. Right? So why we can write it in this form? Like nx. So that is what just we have written here. Nx and we'll get
nx
this.
bar, right? Nx
yeah,
bar.
nx bar, not n. Nx bar. So we'll get here x bar.
So one more reason can be there. Like if we are taking y thing, then we have to put all the values of x in terms of y. We have to just divide it by something or that, something n in y. So if we are using directly this x thing, which is given in terms of x only, and then it would be very easy for us to calculate.
But you can't use x. You have to use x bar only. Because x you can't use, no? Because x from the sample we can get x bar, that mean value, right? Because if you are using directly the x, that means you are just for the same only one what you can say space, one trial, you are directly converting that into normal. So that is not true, right?
Yes, sir. But there's a calculation part in when we are taking this y formula in which y is given, then calculation part would be more considered to this x bar thing. I have used here a y initially for solving the question because I wasn't aware with this formula x bar. So it was taking for me a large time to compute the values.
Okay, but yeah, now you can calculate directly, right?
Yes, sir.
So you can x bar minus, what is that? Mu is given already, right?
Yeah, 600.
Or this sigma is 50 upon
5.
So that is 10. So that you can directly write. So 15 minus 600 upon 10. So 1.5. So fz of 1.5 is the value.
So what you have written here in behind this inequality, below it. So,
Here.
Yeah.
Yeah, it's less than, or you can say less than equals to, that is also fine. Generally the probability of what is that zn equals to something sort of things is, we can write it in the form of fg, right?
So here we are taking all the random variables as continuous, no?
So you can't use this one, equals to, right? Okay.
So in continuous we can say,
yeah, it's better like whatever you're writing equals to or not equals to, both are same.
Okay, sir. So in these courses, which in upcoming weeks we are taking all the random variables as continuous.
Yeah, but no, this question only, no, yeah, for this it is continuous, but for many questions it was discrete also. Like we were solving the first question, it was discrete, right?
Yeah.
It can be discrete, and like because in the binomial, or if I'm doing the binomial or what you can say Bernoulli, that is discrete only, right?
But sir, in this question also you have written p of z less than 0. You have not written p of z less than equals to 0, but then also you have taken it as fz of 0. So if it is less than and equals to, then only we can take it as the form of CDF, na?
No, see, that was discrete, but whenever we have repeated this n number of times, that is converted into normal, right? But normal is continuous distribution, right?
Okay, sir.
So the normal we can write.
Fine.
And Vishal, over here, when we do that 1 minus thing, 1 minus fz, then it is the area which is larger in terms of this particular graph, right?
Not larger area. Whenever we have to calculate, like see, for example, larger area means, see, fz is what? Probability of that z less than equals to z, right? And 1 minus fz of
Yes,
this is
it
what?
will be more.
Yeah, so that is more than that. So, okay, you are asking, okay, so this is not larger area, but this is larger than G.
Okay,
Have you got the
fine.
point? Or
Yeah.
I'm getting confused, like I'm not getting whatever you are asking.
No. Yeah, this is what I meant. What would be the, again, interpretation of 1 minus fz? So that will be normal
Yeah,
distribution greater than that
yeah,
particular
if
value.
this is Z, if somebody has asked regarding this, this is FZ, like, sorry, this is FG, and this is 1 minus FG.
Yeah, the 1 minus fz. Okay, fine.
Yeah.
Okay, so again, this 1 minus fz and the value of probability, they should be, when we are approximating, the actual value that we get by doing the
Yeah, that is,
probability calculation should be near, right?
yeah, so that is not
Should be.
exact, but should be nearly, approximately. Because
Okay.
whenever we have done with the hit and trial method, sir have shown like 2 values. That is why we are doing those things, so like 1 by root upon n, and those things we are doing. Like with the hit and trial, we have got, okay, the value, whatever we are getting after 1 upon root n is approximately same as. That's why we have started with the conclusion we have got, like, it comes in the form of normal, and we have started using them. Yeah.
Is the lecture open at your end? And if you can just move to 42.25.
Okay.
Lecture 7.6, 42.26.
So one clarification. So in activity 7.8, we are doing the question related to mean and variance. So, sir, in this topic, are we going to face only these types of questions where we are asked for the variance and mean or standard deviation, or is it something else that can be asked from us?
This one you're asking?
So in all the questions, we are generally asked to find the mean or variance, or
this just they're asking, okay, if you have been given some sort of IID in the form of normal, so you should be able to remember, okay, that x square will be in the form of gamma, right? And
so
if
can
the
we
gamma
expect any other kind of questions from this lecture, or is this
no,
fine
like,
to just
yeah, it's fine. Like 7.7 and 7.8, just 5 things are there. Like if that is the gamma, what is the mean, alpha by beta. So those things, I guess, will be given in the the formula sheet also. But you should be remembering, okay, if x1, x2, x3 are normal in the form of some 0 sigma square, that is centralized. So that x square should be in the form of what you can say, gamma. Okay, and if we are having and like if I'm having x as gamma, y as gamma also, then x upon x plus y will come in the form of beta, with the alpha and beta, where the mean for that first gamma and second gamma respectively. Okay. And if I'm
so
having,
for these kind of
Vishal, I
for
lose
these
the
lectures,
flow of 7.6, the question that I was asking earlier.
okay,
so I just want to ask, for these kind of questions, we have just considered the mean and variance part. Okay, that's all.
Yeah, that is all.
Okay, sir, thank you.
Sir, and as she has already mentioned, instead of using this traditional y minus n mu divided by root n formula, the x bar minus mu divided by n by, sigma divided by root of n. That seems to be pretty okay. So can we consider it as say this formula as a proper substitute for that y? No, sir.
Yeah. No, nothing, no issue. Only you have to consider that x bar is the mean value, right? It's not, yeah, that's it. 42 point. This one where
1 6, right, Vishwa? So see, that is the thing. You said that probability. I mean, this is what we understand. Probability and 1 minus fz should be approximated. But looking at this, 0.0107 is not a 1 minus fz is not an approximation for this probability. Is the
because
understanding
n
right?
was very less, right? Because n was
Oh, okay.
because we have repeated not like.
But then with n equals 100 also, 1.35 and 9.87,
10 to
they
the
are
power minus
also,
10. So it's closer only. 10 to the power
so we
minus 10 would
consider
be a
that
very,
to be okay.
yeah, it's a very like it's a good approximation. Yeah,
Okay.
and this is a very
But,
like 10, yeah, this is very like
Sir,
yeah.
so this lies in the 10% of the probability, right? In week 8, we have some concept called bias. So within 10% range, this other
Yeah.
probability raise, right?
Yeah. Within
Okay.
10%, everything is fine. Like not even 5, 6, 7% also everything is fine.
okay, fine.
So yeah. Any other questions from activity or practice?
Sir, actually, last that same question I had a doubt, sir. When you are using y, it's 615. Even if you use x bar, is it 615? Yeah, sir. For this particular question,
Okay.
if you go to the top, sir, we are using 615 minus 600 by 110.
Yeah.
Oh. So that's actually the y value, correct? No, sir. 615 is y value.
This x, right? We are using x bar, right?
Even if we use x bar, that we can use 615 over that, because that's the doubt I had, because that's what stops me from using this x bar formula.
Okay, but 615 is the life regarding one life only, right? So 615 we can use now. See, the question is what? The expected life, or what was that? Where is that? This one, right? Find the probability that the random sample of 25 bulb will be having average life. Okay. So x bar is what? 615. 615 should be like x bar, what we can say? That the life of that bulb will be less than equals to less than 615, right? I guess what's that point? What can I say for this?
We are simply multiplying n and dividing by n at the left hand side, so we don't need to change the value in the right hand side. Yes.
Where here? I guess he's asking something different.
Sorry, sir, I got disconnected.
Yeah.
Sir, can you come again? Sorry.
I thought you were asking something different, right? What you were asking?
Generally the thing in the questions, and the questions whatever where they have asked, find the thing, this would be more than the given. Generally they would have given y greater than, say, a particular value.
Yeah. So but here it's not given y, right? Here it has been just asked about the average life. If they have been given in the form of summation, then you can't use, right? Like if they have been given in the form of summation, y is some sort of other thing. Right. But here they have just asked about the average life. So that's why you can use. And yeah.
So wherever they have mentioned this average life kind of thing, we can use this particular formula.
Yeah, you can use, even you can go with the y value also. But the thing is I don't know where you will reach.
I mean, sir, y is actually pretty difficult, sir. Hence, I mean, this is a better alternative. And whenever I use this formula, I got answer up correct. But whenever I try to use
but in this case, why can't I use, and even if I use y, I will just be putting since an IID n into x bar, I can do it. X bar is given 615, so 25 into 615.
Yeah,
won't it
you
give me
can
y?
write. Yeah, you can use that 615 into 25 and then as a y
That's
value.
it.
Yeah,
That's
then you
still
can.
y.
Yeah, then you can get right.
Yeah.
Okay, sir.
But yeah, you're right. Then if the question is formulated in terms of the summation, some limit has been asked, then directly use y. If the average is given, then use the x. Otherwise, also if someone wants to stick to y itself, they just have to multiply n into x bar.
Yeah.
Yeah.
Because this is for one, right? Because for summation, it can't be this all the 25 bulb can't last for 6 input. Like that can last for same. Like it's not asking for all the 25 bulb. It's asking
It's an
just for
average life.
yeah.
Out of the sample of 25, the average is 600.
The average life.
Total
That means it's talking about the one bulb itself.
Yeah, average of those 25 bulbs. Yeah.
So, sir, the 615 value is average life of not 25. It's average life of one bulb. Say correctly in this question.
Yeah, average bulb for one life only. It's one bulb only. Average life means what? It's talking about only one bulb. They have taken 25 bulbs as a sample space. And then he's talking about the average. Like if some bulb is having 1000 and some is having 500. So the average would be 750, right? For both the samples.
Okay, sir. Okay, done. So hence we are using X bar formula. That would be more appropriate in this question.
Yeah.
Okay.
Vishal, I have a doubt in the graded question. I had put it on discourse also, but still struggling with that.
Graded. When is the final? Like it has been already submitted, 7th week.
No, the due date is 16th, but I am not able to understand the question, and I think there is something that might be required to be tweaked.
Yeah. This consists of answer also. I can't show this.
No, that's fine. You can be over here. So, see in the first, in the first question itself.
Okay.
So my doubt is, in order to solve this question, we will come to some point where we will require the variance of x1 also to be calculated.
What is that? X1, X2, X3 are three independent identical. Okay, with mean something that when three formulas. Okay. So yeah, you have to just use the what you can say properties of variance.
So what do we do to calculate variance of x1? Over here we have been given x1, x2, x3. There are three independent.
Here they're not asking the exact value. They're asking just to compare it, right? So that can be in the form of x1, x2, x3 also. But see here it's 1/3 whenever you'll calculate variance of A. So it will come in the form of 1/9, right?
Yes, right.
So but here
the property of square.
Yeah. So those things you have to use and then take some x1, x2, x3 and then see what is the value of A, B, C, and then you can directly like tell about the.
Yeah. So Vishal, what do we do? I mean, variance of x1, x2. How
Just
can we
take
do
some
that
things.
particular permutation combination?
See, just take x1.
Okay, we keep it constant, right?
Some value just take because the variance of x will be some constant value. Take every time x1 as some constant, x2 as some constant, x3 as constant, and put in all the three equations the same value. You will get the.
But is this understanding right that variance of x1, I mean, just looking at this question, I got my doubt cleared, but is the understanding right that variance of x1 is not sigma square? Correct? Variance of x1 is not sigma square.
See, sigma square
is not for x1. In the discourse also, I said to two people that we cannot take the sigma square as variance of x1. It is for x. I mean, this is a distribution, x1, x2, x3 is a distribution for which the variance is sigma square, not that we consider sigma square as the variance of x1.
No, see. Here, see what you are relating with. You are relating with some difference. See, whenever we are having x as a distribution, and from that x distribution, I am taking out some sort of three samples, x1, x2, x3. In that case, the variance won't be same as sigma square, right? But here it's directly given x1, x2, x3 are the distribution with mean as nu and variance as sigma square.
No,
so here
that's not written. It's not the distribution. It's written as random variables. It's not the distribution.
Three independent identical distributed random variables with mean sigma and sigma square. So it's not, just a simple three distribution with mean as what you can say mu and variance as sigma square. Okay. if they have given one distribution and then out of that distribution, if you are taking out of the sum of the samples, then the value will approach to the variance, but it's not the like the variance would be sigma square upon n.
So what I am understanding with this thing, x1, for example, x1, if it is a random variable, it can take any value, 2, 3, one single value, it can take anything, right? This is
Yeah,
what
it
I
can take,
understand.
yeah, it can take anything. X1
Then
can take
how can
anything.
you say, that the variance of x1 is sigma square? I mean, if I say x1 is taking value 3.
See, I'm taking, okay, see, you can take 1, 1, 1 also. Okay.
Yes, then
Yeah,
how
that
will
is
be
fine.
the variance of x1 be sigma square?
So sigma square
If it
can
is
equals to
1,
1, right? Sigma square can equals to 1, right? Sigma square can equals to 5 also. Sigma square can take any values depending
for
upon the
x1,
distribution.
just for x1.
For x2 also, for x3 also, both the three are the independent and identical with some mean and variance. X1 is a one distribution which like this. Some sort of distribution, x1 is this one. And x2 is also same, x3 is also same. With like or same or not, that is not the case. It's having mean and sigma square same for all the three cases, x1, x2, x3. Okay. I'm not taking out the samples. I'm just telling about the distribution itself, x1, x2, and x3. Right? So don't get confused with this question. Like at least you can like whatever the intuition you are getting, it's fine. You are getting confused whenever I'm taking out the x1, x2, x3. So, but maybe this question is not written correctly. That's why you are getting some sort of
Exactly.
so yeah, but I don't think so. But in both the cases, you'll get the, I guess, same answer. If you are taking the variance not as sigma square also, so you can take the sigma x1, the variance of x1, x2, x3 as per your values, but take it constant for every term, and then you can compare. You'll get the answer. Is it fine?
Okay, I'll go ahead with what you were saying, giving some constant value and not going by the question then.
But also you can better to take sigma square every time. Right, or even you will take sigma square by n also, it will not, because you have to compare, right? So even if you are taking sigma square
right,
upon n,
right.
so that will not affect the answer. Okay, that's why maybe the written whatever the line, because that was the comparison thing now. So in this thing, in the comparison, can like this whatever has been written is fine. Like no one can like debate on this regarding the language, but it's fine. Yeah.
If we say that x1, x2, x3 are three distributions.
Yeah, of x, so of some x1, x2, and x3 are some sample distribution, sample values, or what you can say, not sample distribution, some sample values or sample, what you can say, sample distributed random variable of some other distribution x. Or if I'm having, I can say, what you can say, just a sample thing. Like if I'm having some normal distribution already, okay, I'm having already normal distribution with some mean and sigma square, and I'm taking out some of the samples out because I'm having infinite number of values here. For all those values, I'm having some probability density, so I can take out some samples, right? Some n samples we can take out, x1 having n samples, x2 having n samples out of this, right? That will be different for sure, right? For
And
this,
it says for all this, it is mu and sigma square. That is what is the meaning in the question, right?
But it can't
mu and
be.
sigma square for,
But it can't be.
But
If
it
I'm
can't
taking
be, right?
yeah.
But it cannot be, right?
But the thing is, here it has been told x1, x2, x3 are identical. Just for example, I'm telling with mu and sigma square. Okay. This is x1, this is x2, and this is x3. All the three are same, right? Now I'm like, now you're getting, right? It's just a, what you can say, typo
But
or
it
English.
cannot be,
Can
but
be
it
interpreted.
is. It cannot be, but it is the case. Okay, fine. Thank you.
So, sir, I mean, you don't scroll down, sir, but I will tell you two things. You tell me it's correct or not. So the thing, this y and x bar formula, now only I got cleared, sir. So with respect to this, we have a third question, Poisson distribution, which we have to use y formula, and we have no other go. But for the fifth question where there is heads and tails given, we can use the X bar formula.
Yeah.
Correct, no sir? I'm correct in understanding, no sir?
Yeah. But I can't see the fifth question. Yeah, but yeah, whatever you are telling is correct.
Yeah, sir. Okay. Thank you, sir. I mean, that's why I was like, for the fifth question, no sir, I was computing with Y. It was going so bad. Now I got cleared.
Yeah, and you can do it, and see, you can get the idea from the FG also. Whatever the FG has been given, you'll get the answer in the form of that FG only. Like if that has been given FG of 1.5, in the end you'll get in the form of 1.5 sort of things, right?
Yeah,
so
sir.
That
yes.
is also one hint you can see. Yeah.
Okay. Thank you, sir.
Yeah, thank you. So, any other like questions? Like is so see what I can see 7.8 is that. So this one, if you are having any question, you can ask. Otherwise, I'll just go through all the questions. So maybe you won't feel difficulty in solving. So first question, I don't think so anybody will be having problem in this. Second also. Can anybody say if you're having any problem in this 7.8? I guess most of you have not seen the lectures or what, I don't know, because in the discourse also, you're not getting much question from week 7. But this week is not difficult also. That is also one of the case. That can be a case. But do you have like anybody is having any issue in all these 3 questions, 7.8? No? Am I audible? Like, are you able to hear me or
Not gone through the lecture yet personally.
Okay. Then 7th, is there any problem in 7th? So if you are having
the easiest one of the lot, sir. 7th one, if you see the lecture.
Yeah, 7th is simple. I just distribute a lot of things. So if you're having, there will be only one like confusion, gamma and beta. So in gamma, beta, you can directly, the gamma, mostly the X value will be greater than 1, because see, the gamma is simply the, whatever the X to the power some sort of things, X to the power some random values into exponential thing. Okay. In the beta, you'll get in the form of X to the power something into 1 minus X. So the X value will lie from 0 to 1. So you can directly, if you are having some sort of confusion between beta and gamma, so this can be a beta. This also can be a beta. Okay. So one confusion, if you, after watching you'll be having, so this, I don't think so you'll be having problem. So normal, you can directly say, and gamma and beta, if you're having exponential also, you can say directly. The normal, in the gamma and beta, you'll be having problem. But I told the X value for the gamma will be more than 1, and for the beta, it will be from 0 to 1. So now you won't face any problem in that. 7.3 has solved. See, most, you don't have to go through the proof. I'm telling you, just go to the final result and try the question. Just start solving all the question. You'll be able to solve in the exam also. The most of the question will be application based. Whatever has been, like, you can practice more and more, but yeah. So here also 7.6, like everybody has solved. Like, are you having any doubt? Not solved, but what? So what are you posting on the discourse or not? I don't know. I guess most of you have not seen or one. So what you can do, you can just go through the lectures at least today, and if you're having doubt, because tomorrow you'll be having solve with us. So if you are solving tomorrow with Mayur, then you'll be able to solve all the graded question at least. You can submit that. But this week is pretty important. What I can say, you should go through the videos 7.5 and 6 at least twice, and 2 and 4 at least once. 2 and 4, if you'll watch 2, 3, 4, you'll get the basic understanding of the sample mean and all. And 5 and 6 will help you to know about the CLT, and then you can solve. 7 and 8 is pretty simple. Just if you go through the slide also, you'll be able to know everything. Okay. And then what is that? 7.6, like anybody is having any doubt in this? So what I can do is, so most of you have not, like, then what should we do then? Most of you have not solved, or what, you are not getting the time, or what? Can somebody tell me? Like, are you guys sleeping or what? Can somebody reply?
Sir, actually, I also do I also do job. So
Okay.
that's why I didn't get enough time. This week was, I mean, last 1 month was little heavy for me. And so that's why I'm lagging.
Okay.
I'll try to complete it by today so that I'll be ready for tomorrow.
Yeah, so if you're having, if you'll face any problem, you can post it on the Discord, or you can mail me also. And if you're facing like any conceptual clarity in any topic, if you'll mail me, I can discuss it on the event. I'm telling to everyone, I can share the phone number there, and then we can discuss on the phone also. Or if you're facing any conceptual like problem and that for the week 7, or whichever topic you're having facing problem. So yeah. So for now, what
Vishal,
I can, yeah.
Vishal, are you going to share the summary of the formulas that are getting used?
Okay,
Towards the
so
beginning of the course. Today's
yeah,
session you
I
said
told in the starting, but I guess we started discussing something else. So what I can do, I can write and then you can share. Okay, will that be fine? Like, and I can tell the team to share.
Yeah, that will be really helpful. If it can be put as a supplemental one, that will really be helpful.
Yeah, I'll just write it on one page and then I'll share. That will consist of everything. Like with that, you'll be able to solve every questions. That what I can assure. And yeah, that should be there in your mind. What I all the results, final result, and for
Thanks.
so yeah, thank you. So you just go through the lectures once today or tomorrow, whenever you like having
Sir,
time.
or is there any formula sheets are for FZ, like whatever we find in online? I mean, I guess it's fine. It's more or less same. Are there any standard sheets provided to us in the official here, sir?
Which sheet?
So for normal distribution, FZ, say FZ above some value X, Y.
Yeah, in the final, I guess the seed will be provided or the values would be given. So like any of the two can happen. Values would be given for sure. If the question, like most of the questions comes, because in the next week also, not next, but in the 9th or 10th week, the hypothesis testing and all will come. So there you'll be needing this values and all. So I guess now for this quiz, I guess you'll be given the values, not the seed. Okay, that FZ seed, that G testing seed, but you'll get the values. But that will help you, right? Because if I'm giving you 5 values only, so you can predict, okay, so the final conclusion should be in the form of this one, right? So if somebody has a good prediction, he can predict the answers also. Not correctly, but like he can predict a bit, how should I approach it?
Okay, so use the whatever calculators we find online.
Yeah.
Vishal, on the same lines, what is the range of FZ? I mean, I could not figure it out. In some question, it was coming as -14, but when we went online, the distribution table for FZ was just up to -3 to 3. So, is there some range that FZ values fall in, or it can be like -infinity to infinity?
Mostly what I have seen is from -3 to 3, but it can go more also, but the values mostly I've seen in between -3 to 3.
Right,
Which question you
exactly.
have got
Right.
14, I don't know, but mostly I've seen the values from
It was
minus.
again from the graded question
Okay,
that
but
minus
see,
14 was coming, and that is what I was trying to understand whether minus 14 can be right or wrong, so that again I can revise what was the solution.
okay, so but yeah, but I can't. One thing you can do, you can just search on the Google regarding the G test values, okay, and you can see the values from where to where it lies. One that can, or I can see that and can post it or somewhere, because now
G
I'm not
test.
confirmed. G test, yeah, Z.
Z, okay, Z test, okay.
There's a seed generally you will get.
One website did show the value, but again, it was like -4 to 4 only. Not beyond 4, I was able to find in any sheet. Then there are online calculators, but I wasn't sure how to use them for finding Z values.
Yeah, so that is what I also know, that Z value generally is from -3 to 3 or like I'm also searching, I don't know, but yeah, I'll search that and will let you know about the exact value. But if you are getting 0.14, I don't know, but how.
-14.
Okay, yeah, -14 or 14, both will be,
Yeah,
yeah.
okay.
I'll check that and let you know, but -14, I don't think so. But if -14, then the value would be very less, like very less, right?
So there is a post on Discourse also that refers to -14.
Okay, then the value would be very less. Like if fz you have to calculate for that minus less than equals to that -14, then the value would be around 0, right? The probability value would be, because
Yes, right. It will be around 0, correct, right. That is the interpretation. -14, then it should be 0.
Mhm.
But yeah, I mean, I am not sure what
Yeah,
is
I'll
this particular
search.
thing
No, yeah, I'm also
because
not
we don't
confirmed.
know about FZ. We just know till -3 at least. What happens beyond -3, I'm not sure.
So I'm just looking at an online Z table wherein -0.49 gives a value of 0.402, which is very minuscule. So if it
Yeah.
goes further beyond that, then obviously it is going to be further significantly low, very close to 0 in that case.
0, right, right.
Because the left tail further that the area would be very, very insignificant.
That's why we generally consider till like -3 and 3, -3 of sigma and 3 of sigma, so that we'll
Yeah.
at least we'll be having 98% of the data.
Yeah.
And Vishal, to answer your further question as to what is happening with week 7, what I can say is there is not enough time to read more or to understand more than the lectures. Lectures itself are time consuming, and we are at least I'm trying to understand from within the lectures. If there is something that I cannot understand from the lecture, there is not enough time to research on Google and read various website or books and find out. So that is the case, at least with me,
Yeah,
where
that's
I
the
can
case
try
with
to
me too.
interpret. I can interpret what is there in the lecture and try to solve the question in that scope. If there is something more, and there many times it has happened, professor has jumped directly to some third or fourth step from the step 1, and at least I get lost what happened between 1 and 4.
Okay.
Then I again go back to the lectures and spend time, but there is no more time to read on Google what exactly a particular thing means, or read some books on what is more that can be said about that particular thing.
So what you can do, like what I've told, 5th and 6th lecture is like a bit hectic. You can watch it twice maximum, or you can directly go and watch, like some blogs are there related to central limit theorem by some science, what you can say, some popular websites are there. You can just write CLT blog and all. You can get some good blog and you can read on that regarding CLT only, because CLT is the most important thing. Otherwise, everything you can you'll be able to get. CLT you can read from some blog, and that's it. Otherwise, it's there in the lecture. Like you should be able to what you can say. The lecture itself consists of so many, like
Yeah.
in the form of very, like, he has solved everything, I guess.
So for example, concentration phenomena. Now concentration phenomena, I mean, it has been said many times that we can overlook concentration phenomena, right?
Hmm.
Not necessary to spend time on it.
Yeah, yeah.
But then what does that mean? There will not be anything and we can simply skip it? Or do we at least have to get some idea down the line for down the line courses? Then it is fine. But at least for this particular course, can we simply overlook concentration phenomena? Because there are so many distribution. I don't even remember the name right now, but can we simply skip it, the concentration phenomena, or no?
Concentration is not important, and you can't like prepare questions also. Like nobody can will be
Okay,
able to ask
fine.
that also.
Okay.
Yeah, so that is what I think. But it's not important also, I guess.
Okay. Fine.
So, okay, then you should watch the video. What I will say today, at least watch the lectures. I guess today is also not holiday for most of you. Most of you, if you are working, then yeah, so you can watch the videos lecture again. Tomorrow is the solve with us. You can discuss it tomorrow, and whoever is having some doubt in the extra activity can discuss it tomorrow in the starting of the lecture or in the end. So anytime you can discuss it. Like whatever the problem you are getting in, if you are not able to plot that graph or distribution in the form of normal, you can just ask Mayur tomorrow in the starting of the lecture, or you can session, or in the end. Anything is fine. Or if you are facing any doubt before, if you are facing any doubt to solve the question, you can post on the discourse, or you can mail me if not getting replied from the discourse. So you can mail me, and then if you are facing some concept clarity, that also we can discuss with some Google, like I'll share the Google Meet link on the phone, so we can discuss that. So well, it's fine for you all, then yeah. So what is that? Okay, you can mail me regarding this on the, okay, Ranjit. I'll just post my, what you can say, mail ID. You can just ask it there.
Okay. So do we conclude today's session here?
Yeah, because nobody's asking anything then. So if you're facing doubt, I'll share the mail ID. So you can just
Okay,
ask.
I just got it.
Yeah, so this is the mail
Sure.
ID. So yeah.
Vishal, on which head under discourse will you post the formula sheet?
I'll just tell the team to share it on the portal itself. Okay.
Under supplementary content?
Yeah, so I'll just write it down now itself, and then I'll share it by tonight. Okay.
Sure, thank you.
Yeah. So Ranjit, you can just mail me. I'll just send you the contact number. Then if you're facing any doubt, we can discuss. Or I'll share some
Sure.
Google. Yeah.
Sure, that helps. Thanks a lot, Vishal.
Yeah. So thank you everyone. Then we'll close the session now. So just go and watch the videos. It's important. So you should watch all the content, and then you can go through the questions if you are facing any doubt. Otherwise, you can mail me, or any sort of thing you can do. I'll try to discuss that. Okay.
Okay, great. Thank you.
Yeah. Okay.
Thank
then.
you.
Yeah. Thank you. Thank you, everyone.
Thank you very much, Vishal.
Thank you,
Thank
sir.
you.
Yeah. Thank you. Thank you.